Hey everybody, we're going to move into Chapter 5, Section 2, which is about polynomials, linear factors, and zeros. We're going to analyze them and we're going to write a polynomial function. So it'll be like x squared plus 2x or something like that. So part 1 is going to happen pretty quickly because you are very good at factoring by now in this point of Algebra 2. So we need to be able to fully factor a polynomial. So problem 1 wants us to factor the following polynomial completely. So we have this polynomial. It's a cubic trinomial. First step is that GCF of x, which we are used to looking for, which will give us 2x squared minus 7x minus 15. And then when we look at this quadratic trinomial, we are either going to use the box method or the grouping method. So I will quickly do the grouping, or actually I'll do the box method, but you can absolutely pause and do grouping. Please remember AC goes over here and B goes over here. My magic numbers are going to be not 15 and 2, let's see, 3 and negative 10. So when I move to the box, I have 2x squared. Let's zoom in a little more. And negative 15. My magic numbers were 3 and negative 10. If you're not I don't know what you're doing, please go back and revisit 4. Take the GCF of 1x out, take the GCF of negative 5 out, take the GCF of 2x out, and then GCF of positive 3. So for fully factored form, I will have an x on the outside. I will have a 2x plus 3. And I'm going to have an x take away 5. And let's check that out. That looks good. Just double checking negative 10, positive 3, negative 15, looking good. So fully factored form, it has 3 factors. The first factor is x, then 2x plus 3, then x minus 5. All right. Now, part 2 of this assignment, or these notes, concepts, how do you find the zeros of a polynomial and how do you use those zeros to graph? So we're going to find the zeros and then we're going to graph using those zeros. So I have what I'm hoping are some clearly labeled steps for you. The first thing we're going to do is we're going to find the zeros by factoring the equations. Make sure to look out for GCFs. We're going to plug those in to get some y's. We'll find points in between those x's, even if we need a decimal. Plug those in, graph our points. Let's take a look at the polynomial here. Find the zeros, okay? Use them to graph the following polynomial. So this polynomial, to save time, I already factored this. You should be able to factor yourself, at least on most quadratics, but this one's already been factored. So this first x up here would be a 0 of 0. This would be x plus 1 is 0, or maybe you guys are able to get the negative 1 right away. This would be x minus 4 is 0, or maybe you could get positive 4 right away. This would be 2x minus 3 is 0, and add 3, divide by 2. X would be positive 3 over 2. So just did some algebra 1 there. Set each factor equal to 0, and all of those are your zeros. So you know what's actually going to be better? If we use 1.5 here instead. That's going to help us graph. So I am going to make an XY chart because the directions said to graph those. Let's find my lowest. The lowest one is negative 1. So I need to do negative 1 and 1 smaller than negative 1 because I need to know how it behaves on the other side of it. Then I'm going to move up. Let's see, what's your highest one? Your highest one's 4, right? So I'm going to need to go all the way to at least positive 4 and 1 higher. That way you know how it behaves. So you do your lowest, you do your highest, and 1 on either side of it. Now I'm going to fill this chart in. So I need to do all the way from 0, 1, 2, 3. Oh, I did that pretty spot on. Now let's see, where are my other zeros? I have a 0 at 0. I have a 0 at 1.5. Oh, I don't have that one in there, do I? I don't have 1.5 in there, so let's get it fit in there. Let's see, so it's going to be 1, 1.5, 2, 3. Okay, now what I need you to notice here is that I have all my zeros, boom, 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 and boom, but bummer. I don't have remember the directions said you have to have some that are in between all your zeros. So what I need to do is, because you need to know how it acts. How does the graph act between your zeros? So I'm going to move this down so I can get an in between here of negative 0.5. All right, so I still have my zeros. I have a number in between, and now I'm going to use my handy dandy calculator to type in my equation. And you can see this over here on the side. Um, you're more than welcome, obviously, anytime to pause the video and go through and make sure that you are following along. Okay, I think I got them all in there. At least I hope I got them all in there. Plus 1, minus 4, 2x minus 3. And now I'm going to hit Shift and Table and type in my x's so I can plug them in quickly. You can plug them in by hand, by all means. Negative 2 is going to give me, oh, 84. Yikes. Negative 1 is going to give me 0. And if it didn't, we'd have a problem. Negative 0.5 is going to give me negative 4.5. 0 should give me a 0 since it is a 0. 1 should give me 6. 1.5 should give me 0. 2 is negative 12. 3 is negative 36. 4 is 0. And 5 is, whoa, 210. That's obnoxious. Okay, let's hit graph just so we can kind of see. Invalid dimensions, my bad. That's all right. We're just graph it ourselves. We don't need that. Um, let's go ahead and I have a chart here. I'm going to count by tens because this is a very, very, very widespread graph. So on my y-axis, I will go by tens. And on my x-axis, I'll go by ones. Negative 2 and 84. Here's negative 2, 10, 20, 30, 40, 50, 60. Ah, even ran out of room there, didn't I? Sorry, 10, 20, 30, 40, 50, 60, 70, 84-ish. That's fine. That's good enough. It's eyeballing it. Negative 1, 0. Change that pen size to be a little bigger, I think would be good. Yeah, that'll be nice. Negative 0.5 and 4.5. So that's, or negative 4.5. That's going to be like here. Okay, I'm going to clean up that dot because that was really an ugly one. There we go. 0, 0. That's easy to graph. 1, 6 won't be too bad. Remember, I'm counting by tens on my y-axis. 1.5 and 0. 2 and negative 12. Remember, you're counting by tens. Let's see. 3 and negative 36. So here's 3, 10, 20, 36. 10, 20, 36. 4 and 0. 5 and 210, it's just like way up there. I mean, like way up there, okay? So here's what we're going to do. We're just going to give ourselves a very nice graph. It looks like it's going to connect like boom, 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 and it's going to shoot way up there. So I'm not going to graph that. I just know that it has to go really high up. And if my calculator were behaving, I could definitely type this into Desmos. Maybe I'll do that. I'm going to grab Desmos. I'll try to edit this part out of the video if I have time. Hey guys, I typed this into Desmos and you can definitely see that it does match the shape that we were going after. You can even see those important turning points and zeros there, but that's how you use your zeros to help you graph. Just for re-emphasis, I found all the zeros and I put them on my chart. 1, 2, 3, 4 of them. I made sure to pick x's lower and higher, and I made sure there was an in-between value on all of them. All right, let's take a look at what is next, and that will be part 3. So part 3, we are going to write and develop, however you would, whichever one makes you feel smarter, a polynomial function given the zeros. So instead of, it's opposite. Instead of having the function and finding the zeros, we're going to be given the zeros and finding the function. Nice little inverse of each other there. So I have my steps here on how to do this. This one tells us we're going to get a cubic function, and we need that cubic function to have these zeros. So in other words, this is where it's going to cross the x-axis, also known as its roots. Step 1, make the x equal the given root, and then set those equal to 0. Okay, so I see x needs to equal -2, x needs to equal +2, and x needs to equal +3. Then my directions say to set those equal to 0. So adding 2, I get x plus 2 would be a root. Subtracting 2, x minus 2 would be a root. And subtracting 3, x minus 3 would be a root, because the roots always have to equal 0. Next, this is what would belong in the parentheses. So my polynomial function would be made up of x plus 2, x minus 2, and x minus 3, highlighting those in red so you see where I got those from. Now I need to multiply the polynomials together. So I am going to do the ones that are conjugates if possible. Now I just said a really fancy word. I said conjugates if possible. I am praying that you remember that x plus 2 and x minus 2 are conjugates of each other. So I'm going to multiply those together first. So I will do x times x is x squared minus 2x plus 2x minus 4. I'm just doing the purple ones first. I'll deal with the red one in a second. That will reduce to x squared, take away 4. Conjugates are nice like that. Please don't forget that we had the red one, x minus 3. Now I will do, I can stick with the pink, right? X squared times x is x cubed minus 3x squared minus 4x plus 12. And because I don't want to redo my video, I'm just double checking. All right, that looks good to me. This is the polynomial function. Now, if you're like me, you like to see what just happened. If you're not like me, then you might want to skip this part and just take it for what it's worth. I'm going to type in my answer, x to the third minus 3x squared minus 4x plus 12. And I would like for you to see that sure enough, let's see if I can stretch this out to see it better. Woo, that was kind of loop-de-loo, wasn't it? I see that it does in fact cross at -2, it crosses at +2, and it crosses at +3. And you can see those were all the zeros they told me about. Now, that didn't seem that hard, and the reason was because we had a really nice conjugate to work with. Now, this one is harder, okay? What is the polynomial function? Now, look, in the last problem I told you it was cubic, didn't I? That's because it ended with the highest degree of 3. This one I'm not telling you. So at the end, let's go ahead and name it, as long as I can remember. Now look, you have 4 zeros. Ay, 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 ay. Just so you know, that means x to the 4th power, or quartic. Oh, I just kind of ruined that fun, didn't I? Let's go through our steps. So if x equals -2 twice, yes, you do have to write it twice. So these are all the roots. So when I kind of set them all equal to 0, we'll get x plus 2 twice. And that's okay. Nothing wrong with that. This one will be x minus 2. This one will be x minus 3. I kind of skipped a step there. Call me over tomorrow if you're like, I don't know how you got those. I'd be happy to explain. So those are my roots, and now I can put those into my polynomial function. So those roots would have come from x plus 2 x plus 2, x minus 2, and x minus 3. And now that is the polynomial function, but it's not in standard form. And of course, I didn't read the directions. I'm so sorry. I knew what I needed. They need to go in standard form. I would highly, highly, highly encourage you not to write x plus 2 squared. So some students think you can distribute the squared. That is the top 10 in the top 10 mistakes of an algebra student. So what I'm going to actually have you do, now do it or don't do it, your decision. I would highly suggest putting the conjugate next to itself there as the first two to multiply because it's really going to simplify. Now, are you ready? Because we got to put our big boy and our big girl pants on and go. So we're going to get x squared, take away 2x, add 2x minus 4. Now remember, guys, all I'm doing are the first two. I still have two more to deal with. That is going to be x squared minus 4. Thank you, conjugates, because those cancel. I love it when a problem has a conjugate to it. All right, now all of that was from the purple. Now it is time for us to do the yellows together. A little more challenging. That would make x squared minus 3x plus 2x minus 6. And you might say, Miss Angeli, that was not more challenging. I could do that on my sleep. Oh, good. But, you know, can anybody see why it's going to be more challenging? When I put those together, I still have a trinomial to deal with. Well, guys, unlike the last problem, we have one more beloved step to do, and that is going to be to put the purple and the yellow together. And just because I want to, purple and yellow makes brown if you were to mix them in real life. So we'll do x times x squared. You better get ready for a lot of distribution. X to the fourth minus 1x to the third there, adding our exponents, minus 6x squared. I am going slow because I don't want to screw it up. Minus 4x squared plus 4x plus 24. Oh, that one wasn't horrible. They do get worse. If you're wondering, oh, I wonder if it gets any worse than that. Yes, it does. All right, because you might have like 9 arcs. If the conjugate hadn't happened, you would have a 3 thing times a 3, a trinomial times a trinomial. Okay, so let's see. That's x to the fourth. Take away x to the third. Take away 10x squared. Add 4x, add 24. Now, before I do anything, I want to make sure that matches my answer key, which it does. There is my polynomial function. If anybody has any interest, you can definitely put this brown highlight in a calculator, and you will see it crossing at your roots from way up there, or your zeros. I do have this on this part C. I ask you to compare the graphs. I am going to stop the video here and cut in to an old video of me explaining how the graphs compare to each other.